All right, this is lesson 1-8, the mean value theorem. We abbreviate mean value theorem by saying MVT. All right, I already have some graph on here. Oh, come on now. There we go. So review from yesterday, what is differentiability? You are able to differentiate at any point or at some point, and you're able to draw a tangent line. So let's look at this graph. So this graph is f of x. So when I look at f of 1, is this function differentiable at this point? What do you guys think? You can talk here.
Oh, wait, ask again?
Is this point differentiable at f of 1?
Yes.
It is differentiable. So the f prime does exist. So f prime of 1 does exist. And what is the slope of the tangent if I drew it here? Is it positive, negative, or is it equal to 0?
It is positive.
It is positive, greater than 0. All right, let's do f of 2. So this is, I'm going to write underneath f of 2, or sorry, f prime of 2. So that's the slope at 2. That's the slope of the tangent at 2 if I drew it. And I can kind of, oh, that is not the line that I wanted to draw. Ah, my gosh, this pen is so bad. Whatever. You guys can probably tell what the line looks like. All right, what is the slope of that line? F prime of 2 is?
0.
It's 0, yeah.
Yeah.
It's a flat line. Remember, if it's a straight up and down line, it's a DNE. If it's straight across, it's 0. All right, let's look at f prime of 3. I should do this in another color.
Can we say hi to Isabel?
Sure.
Hi, Isabel! Hi, Isabel! We miss you!
All right. We all miss you, Isabel. All right. F prime of 3. F prime of 3. Does it exist?
Yes.
Okay. And then what is the slope then?
It's negative.
It's negative. It is less than 0. It's a little bit hard to see on here. It's easier to see on the main screen. All right. Let's look at f prime of 4. So come down here. I'll use black. I'm going to write underneath f prime of 4.
It's DNE.
Oh, what happened to my pen width? My pen width got all messed up. And I already hear you guys correctly say it is DNE. F prime of 4, DNE. Can you explain why?
Because it's an angle. There's an angle.
Angle, sharp angle, yeah. Sharp, and then you can say edge or angle. I'm going to say edge.
Can I say sharp point?
Point doesn't really have something that's sharp. A point just is.
Well, you told me yesterday.
Okay, well, I'm sorry. I'm changing it now. It's a sharp edge or a sharp angle.
You told me.
All right.
You told me sharp corner.
Sharp corner, that's even better.
Okay.
5. F prime of 5.
It's DNE because it's a gap or a hole. Or
It's one of those. DNE because a gap or a hole. It's a... Everyone else shout it out? Or at least take a guess. DNE because...
It's a hole. VA.
It's not a VA. I heard it out there. It's a hole.
It's a hole. Wait, we've been saying it. Yeah.
I heard it from the beginning from some of you, but not everyone had it. All right, and then what about at 6? Let's do this in blue. So this point right here. F prime of 6. What is this?
End point. No. Yeah, it's an end point. So DNE.
DNE endpoint. And we'll do in here endpoint. Beautiful. We remember from yesterday. Okay. So let's go ahead and learn the mean value theorem. Let's come down here. I think, okay, I'm scared that I'm not going to be able to have enough room, so I'm going to go to a new slide.
Wait, I needed a...
I knew there were going to be screams. Okay, well, we'll pause here for a sec.
I see it quivering. I see your pencil moving. Why are you... Okay.
All right. Again, differentiability, there are 4 definitions. F prime exists. It means it's differentiable. What were some of the other ones? I know them, but I'm going to give these out.
Derivative?
Derivative? No, it's derivative.
Okay, same thing. I tried.
It means we can draw what?
A tangent line.
We can draw a tangent line. Yeah.
Okay,
Remember the 4th one?
go on.
Okay, we're going to move on.
Wait, I don't know
from the notes from yesterday. There were 4 things that were equal to each other.
Oh, yeah, it was. Instantaneous rate, derivative, tangent with tangent line, and F prime.
Yes, so Isabel, look at your notes because I don't think you were able to hear them.
We didn't hear you.
Okay, let's move on to this category, the mean value theorem. And we abbreviate this with what again? MVT. It's the meanest of them all. All right. So what does mean mean again? What is the definition of mean?
Average.
Yeah, average. Thank you, Joy. So mean, oh, come on. Come on here, pen. It's like failing me. Mean, yeah, quotation marks. Mean is average. I'm just going to abbreviate. Average.
Mr. Sindel, can I go get the string cheese from my classroom? I'm like really shaky.
You can do, this is the last slide, so get the string cheese right after this. This will take 5 minutes, and then you can get string cheese for working on the problem. All right, so let's assume I have a graph, and I'm just feeling like the graph should look like this. All right. So what is the average rate? How do I draw average rate again? Do we remember?
Like a line. Draw from
Oh, yeah, from the
points.
point
Yeah.
to point.
Yeah, from the start to the end, you just straight line. Okay, it should have been straighter, but I tried. And that is, again, the average rate. Okay, so the instantaneous rate is going to be just at a point. This is the average rate. So what is average rate? I'm going to do a little bit of a review down here. Average rate again. The formula.
Derivative.
No derivative.
No, it's F of B.
F of B
Minus F of A over
minus F of A
B minus
over.
A.
Yep, B minus A. Carly gets it. And if in terms of B and A on our graph, this would be our A, this would be our B. It's the end minus the start. Perfect. All right, and then another thing that we need to remember is instantaneous rate, just the symbolic form of instantaneous rate. Let me write instantaneous rate here. Instantaneous rate. And by the way, after this category, we're done with our notes. Instantaneous rate. What is the notation for instantaneous rate? It was one of the things that was equal to, one of the 4 things equal to in our last notes. Derivative, but the notation.
F prime.
F prime, beautiful. F prime. And at a certain point, C. So instantaneous at a certain point is equal to F prime of C. All right, we'll get questions at the end. So this is what the mean value theorem says. It says that if you have a continuous, okay, I should write these down. You need 2 things. And I'll write them in the side notes. Just like EVT and IVT need things, this is what they need. This is what the MVT needs. It needs to be first continuous, and second, it needs to be differentiable. And we just learned what differentiable means in our last slide and in yesterday's notes. I'm just going to say diff, and then hopefully we all know that's differentiable. Those are the 2 things that you need for MVT. If you see those 2 things, go ahead and apply it. So, assuming that this function is continuous and differentiable, obviously it's differentiable not at A and not at B. So if I was doing differentiable here, it's differentiable with curly brackets because it can't be differentiable at the endpoints, right? If I did square brackets, then it wouldn't work. It's not including those points. We can't include the endpoints. Okay, so the mean value theorem states that the average rate between A and B, somewhere between there at least once, the instantaneous rate will be equal to the average rate. I'll say that again. Somewhere between A and B, assuming these 2 conditions are met, the instantaneous rate will equal the average rate. It guarantees it at least once. It might be an infinite number of times, it might be twice, but it guarantees at least once. So yeah, let's say MVT states, assuming that the conditions have been met, MVT
Silly goose.
those 2 things are equal at least once.
So it's saying that if it is differentiable and continuous, then there must be a point.
At least once. The instantaneous rate must equal the average rate. So what does that look like on a graph? That's what I really care about. Let's look at the instantaneous rate. Again, I'm color coding here. Instantaneous rate is red. So if the average rate was like that, we practiced yesterday drawing instantaneous rate. We practiced drawing tangent line. Where is the tangent line going to be equal to that average rate? Well, I would say right about there, because the tangent line looks like that. Look how the slopes are the same. There's another one on here. Do you guys see it? Think about it in your minds.
It's the bottom one.
Somewhere over here. Do you guys see it?
It's right there.
Right there. It might be a little bit up.
Where we can draw a tangent?
A tangent line that is parallel to the average rate.
Oh.
So there's the tangent. Okay, my line should have been better, but that's also another place where the tangent line is equal to the average rate line. The slopes are equal, I should say. All right, and that's really all we need to talk about. And I guess I should annotate the graph by saying that's instantaneous.
Is the MVP part or MVP part the most important part? Should we start with the
MVT is the most important. I mean, this is the only new thing that we've learned today. So if you want to start, sure. I mean, the definition in our last slide was the MVT, and I've only given you one thing on MVT. So yes, this is the most important thing. It's really hard to get our heads around this, but there's at least 1 point that is equal, 1 point between this interval A and B, not including A and B, where the average rate is equal to the instantaneous
And
rate.
that's only if the line is differentiable?
That's only if it's differentiable and,
Continue.
yeah, and actually I haven't said this before, but if it's differentiable, it also is continuous. So technically you only need 2, so I'll make a note of that by just writing a star, because differentiable implies continuous. Because you can't be differentiable. Like, assume that you were differentiable. How is it impossible, or how is it possible to not be continuous? Because part of the definition of differentiable is that it is continuous. Okay, so technically you only need differentiable, and that ends the notes. Go ahead and write your summaries now.
Say goodbye to
Okay, say goodbye to Isabel.